Hello, Nick.
Hello,
How are you today?
I'm good. How are you?
Good. So,
Good.
what do we got today?
Well, I have this Unit 3 review sheet.
Okay.
We can,
Can you
alright,
can you verbalize everything on it, or do you need to take a picture of it and send it to my email?
I can verbalize it.
Okay. What do you got?
The first one is find the sum or difference of each expression.
Okay.
And my first one is parentheses 10a squared plus 7a minus 5 parentheses plus parentheses negative 7a squared minus 6a.
Minus 6a.
Yes,
Okay.
minus 11.
Plus 11.
Minus 11.
Okay. The first thing here is to get rid of the parentheses,
Mm-hmm.
then combine like terms.
Okay.
I never really need these initial parentheses ever. They're pretty much just for clarification.
Mm-hmm.
And it turns out I don't need this set of parentheses because I'm adding everything. In other words,
Yeah.
as long as that's a plus sign, I can remove the parentheses and the plus sign and everything's copacetic.
All right.
It only becomes a problem if this is a minus sign, and then that negative sign has to be distributed to every term.
Yeah.
Well, since this is a plus, I can erase that, and erase the plus sign.
Okay.
Now combine all like terms. How many a squareds do we have?
Well, we have 10a squared minus 7a squared, which is 3a squared.
Our total number of a's.
Yeah. Now we have 7a minus 6a, which is 1a. We plus 1a.
And the numbers?
Um, negative 5 minus 11, which is negative 16.
There you
No,
go.
it's positive.
No, it's negative. In other
Oh,
words,
okay.
the negative 5 minus an 11, this is the subtraction. So if we turn it into an addition problem, I change that to an addition and change the sign on what is being added.
All right.
Now you have minus 5 plus minus 11.
All
Clearly,
right.
clearly minus 16.
Mm-hmm.
Um, do you happen to have one that has a minus sign in front of the second?
I do.
Good. Let's do that one because that's the only ones that are going to be tricky for you.
All right. It's parentheses 3x squared minus 5x plus 1 parentheses minus parentheses 9x squared minus 3x minus 1.
Now remove both sets of parentheses and tell me what to write. Without combining them, just remove the parentheses.
Okay. So would it be 3x squared minus 5x plus 1 plus 9x squared?
Well, just you don't need the plus. Just minus not. Is that what you said? For some reason, I'm missing the sign when you say it. But what's the next term?
Minus 3x.
Hold on. This minus has to go and be distributed to all three terms. I distributed it to the 9x squared. That's how it got to be minus 9x squared. What's the next term? What's minus times the minus?
It's a positive.
That's plus 3x plus 1.
Alright.
Now combine like terms.
Okay. So we have negative 6x squared minus 2x plus 2.
Good. That's all there is to adding and subtracting polynomials. It's that simple. The only mistake you can make is when not distributing that negative sign to everything in the parentheses.
Okay.
In other words, I'm going to use the same rules. I'm going to turn it into an addition problem, and then I'm going to make that minus, I'm going to make that plus, I'm going to make that plus, I'm going to remove the parentheses, and now when I have a plus and a minus together, I can remove the plus. Never needed those parentheses anyway, so I get that, which is the same as that.
Yes.
All right. What else you got?
Okay, so I have to find the product of each expression.
Okay.
We have negative 8n cubed no parentheses at the beginning.
Okay.
So after the negative 8n cubed, we have a parentheses. 5n squared minus 3n plus 7.
Okay.
Yep.
How do you do this one?
Would you distribute the negative 8n cubed into...
Into each term.
Yeah.
Okay. And in so doing, you basically are removing the parentheses. So what's the next line? In other words, what is this term times that term? That's first step.
Would that be 40n cubed?
Well, first of all, minus 40, because it's minus 8 times 5. And then what is n cubed times n squared equal to? Add the exponents. Since they're giving you this problem, we better go over this. Follow my logic.
Alright.
I am multiplying the bases. Therefore, I'm going to do one level less mathematically with the exponents. I'm going to add them.
Yeah.
If I am dividing the bases, I'm going to do one level left with the exponent. I'm going to subtract them.
Okay.
And if I am exponentiating, or what I call double exponentiation, I'm going to do one level less mathematically, which is multiplication.
All right.
That's how you handle exponents. That's really the only 3 rules you really need for exponents.
Okay.
Okay? So, back to that problem.
Okay.
Let's finish it. What's this times this equal to?
Is negative 40 n.
What power? I'm multiplying
n to the power of 6.
adding.
Oh, to the power of 5.
Right. Now, the mistake you just made there,
Yeah.
you were multiplying the bases and you multiplied the exponent. So always remember, you never do the same thing to the exponents that you do to the base. You'll do one thing less. And what's less than multiplication? Addition.
Yes.
So that's the way to remember it. Only time you multiply the exponents is if you're doing double exponentiation. In other words, if I had n cubed and then was squaring the whole thing, then I'm going to multiply, and that's equal to n to the 6th. All right?
Yeah.
All right, what's the rest of it?
Then we distribute the nx cubed into the rest of the
That whole thing is multiplying each term, basically.
so then we have positive 24 24 and to the power of 4.
How much power?
The power of...
You said it. I think I just misheard it.
Yeah.
You said 4?
Yeah.
Good, because there's a 1 there. So
yeah.
We're adding those two exponents, okay? And then what's the last term?
We have 64n cubed.
Minus.
Yeah, minus 64.
And it's 56.
Oh, sorry.
All right. N cubed is correct.
Yeah.
In other words, you're doing that one, and then you're doing that one, and then you're doing that one.
Yeah.
Okay? What else? Division? Because division can be a little challenging.
No, she didn't give us any of that.
Okay.
I'll do one more of those. We have parentheses 2x plus 1.
Okay. So you got a binomial that's going to multiply another binomial. It's the second one.
Oh no, it's parentheses 2x plus 1, and then outside of that is squared.
Okay, and that actually means this, correct?
Yes.
So I'll skip the step. I normally would have put the squared there, and then I would have said that means multiplied by itself. Okay. Did they teach you FOIL?
No.
So when they taught you to multiply these, they just told you multiply every term by every term?
Yes.
I'm going to mention FOIL to you, even though I don't like it. The F stands for the first. The O stands for the outside. The I stands for the inside, and that stands for last. So the first is that times that.
Yeah.
The second, or the outside, are the outsides times one another.
Yeah.
Insides times one another, and the last would be that. So let's go in that order. Let's go black, blue, green, red, and always go in the same order. In other words, don't mix it up. Don't do the blue or the black first, and then the red, and then the green, and then the blue. Do them in an order. You don't have to necessarily know FOIL. And the only reason I don't like FOIL is it doesn't work very well when you have a binomial term times a trinomial. If you have 3 terms over here, FOIL doesn't really apply.
Yeah.
But what always applies is ET, ET. That's what I teach if I'm teaching it. ET, ET means every term by every term. So if I have 3 terms times another expression that has 3 terms in it, I'm doing every term by every term. So you know what I mean by that?
Yeah.
Okay. So let's get an answer here. Let's erase FOIL. I'm not anxious for you to know FOIL, but in case you ever heard it. All right. So what's the black?
The black is 4x squared.
What's the blue?
The blue is 2x.
What's the green?
Also 2x.
And what's the red?
1.
Notice that you only have one of those and you only have one number, but the middle 2 terms frequently combine, and you have to do so. In other words, this isn't a good answer because I can add those 2 together. They're like terms. So it's 4x squared plus how many x?
4x.
Okay. Plus 1. That's your answer.
All right.
What else you got?
Um, okay, I have this, okay, so it asks you to find the area of this picture.
Okay, that's probably, unless it's a picture that you can describe, assume it's
Yeah,
not a circle, or is it a triangle, or
it's a cube, but there's an inside and an outside. There's like a frame.
oh, it's like this.
Yeah,
And they want the area of the shaded region?
no, of the inside.
Oh, just the inside?
Yeah, and then the second one of is
What
the picture
what
and frame.
dimensions? You said a cube, but did you mean a square? You must have meant a square.
It's like a rectangle.
A cube is three-dimensional.
Yeah, it's actually a rectangle.
Okay, so it's more like this, surrounded by something.
Yeah.
What dimensions do they give you?
The inside, the long way is x plus 6 inches, and then the other side is x plus 3 inches.
X plus 3?
Yeah,
And that applies to the inside?
yeah. And then for the frame, the long way is 2x plus 3. The other way is 2x minus 2.
Okay. If I'm
So we need.
looking for the area of the red,
Yeah, that's the first part. That's the first question.
because I don't really care what the outside dimensions are, it doesn't affect the area of the red. What's the area?
Yeah, but I need to find that area afterwards.
Okay, so let's get the area of the red. What's that going to be?
Um, x plus 3 times x plus 6.
Okay, do that math.
Should I use FOIL?
Or ET, either one.
Okay. So first we have
Get in the habit of doing it the same way. My only caution is don't jump around. Whatever you use, the way I do it is I just go from left to right. So I'm going to start with this term on the far left, and I'm going to multiply that term, and then I'm going to take that same term and multiply the other, and then I'm going to start with the next term and do the same thing.
Mhm.
Use a method that is the same. Don't mix it up. So what's that equal to?
So we have x6.
Hold on. Very first step's going to be that. Always.
X squared plus.
Finish that term. Finish multiplying that term by every term that's on the right.
Multiplying the x squared by every term.
No? In other words,
Just the.
we're still foiling this thing.
Yeah.
Now, FOIL happens to go in the exact order that I like. In other words, you start with the first term, multiply it by both. So the first term is x squared, the second term is x times 6.
All right.
Now I'm done with this x here. So next thing to consider is the 3. Next term is 3 times the x. Last term is 3 times the 6. Simplify that.
Okay. And then we have Do I just add them together?
Well, the only two terms you can add together are the like terms.
Yeah. So x6 plus 9x plus 18.
You meant x squared.
X squared plus 9x plus 18.
That's why I was confused, as you were saying x6, and I didn't know what you meant. Okay, so that's the area of the red. Now they probably want the area of the frame itself, right?
Yeah. Then they want the area of both the frame and the picture.
Okay, so let's do that. So I'll use blue for that. So what times what?
2x minus squared times 2x plus.
Do that multiplication?
Yes.
No, go ahead and do it. I'll write it term for term.
Alright, first we have 4x squared. Then 6x
Okay, you need the sign in front of it. If I just write 6x, it has no meaning.
plus 6x.
Okay?
Then minus 6x.
Minus what?
6x
No, the next term is that times that.
minus 4x.
Okay?
And then plus 6.
Okay, the last term is that times that.
Yeah.
What is that?
Negative 2 times 3, which is
Negative 6.
negative 6. Yeah, minus 6.
Okay? Now combine the two middle terms. Like
So we got
every time you have this kind of a problem, you can always combine those two middle terms.
yeah. So 4x squared plus 2x minus 6.
Okay. Now, if that's the area of the inside rectangle, and that's the area of the full outside rectangle,
Yeah, now we need the frame.
so the green area, how are we going to get it?
Subtract the area of the hole from the inside.
Correct.
Yeah.
Shaded region problems are always subtraction problems. Just remember that. In other words, if they want the shaded region in geometry of that right there, I'm going to take the area of the outside circle and subtract the area of the inside circle. And that gives me that similar problem as this. But just remember that when you get to geometry, shaded region problems, which are very common, are always subtraction problems.
Yeah.
So I'm going to take the blue and subtract the black, right?
Yeah.
Let me erase the picture. That's the only last thing we need to do, correct?
Mhm.
Okay. So subtract. Here, let me write it like this and make it a little bit easier. If you write them vertically, I don't know if that makes it easier for you or not. It might make it easier for some people rather than, you know what I mean by writing it horizontally. In other words,
Yeah.
if I do it the way that we were doing these problems, I would put a parentheses around there and I would subtract, and over here I would do it like this. Maybe we should write it like that because that's what you have experience doing.
Mm-hmm.
I don't want to confuse you by giving you two different ways to do it. Now, let's make sure you can do this again. What's the first step?
Subtract the like terms.
Remove the parentheses. That's always
Oh, yeah.
the first step. And that's the hardest step. Combining like terms after you get rid of the parentheses is easy.
Mm-hmm.
But removing the parentheses is tough because that's a subtraction right there. So
Yeah.
remove both sets of parentheses and tell me what, before I combine anything, just remove the parentheses.
4x squared plus 2x minus 6 minus x squared minus 9x minus 18.
Good. Now combine like terms.
Alright, so 4x squared minus x squared is 3x squared. And 2x minus 9x is
What's the, oh, go ahead, sorry.
negative 7x. And negative 6 minus 18 is a negative 24.
Uh-huh.
positive. No, yeah, negative 24.
No, it's negative.
Yeah, okay.
This is another, believe it or not, this is one of the hardest things I deal with, is getting people to understand how to do that.
Really?
Yep. They're confused by all the negative signs. And the reason this is confusing is because this is the subtraction. That is a negative sign. They're not the same thing.
Yeah.
They look the same. And they have a lot of properties that are similar, but they're not the same thing. So identify the subtraction sign, change it to an addition sign, and then anything that's affected by that subtraction sign, you have to change the sign on it. We were subtracting a positive 9. Now we're going to add a negative 9.
Yeah.
Then nobody has a problem with this. Everybody knows how to do that. So when you convert it to an addition problem, it makes it a lot easier. And that's essentially what we did in this step when we removed the parentheses, was that I turned that into a plus, and then I made that a minus, that a minus, and that a minus.
Yeah.
And the only thing I have is a plus next to a minus, and you can get rid of the plus whenever you see that. So that's the secret. But I've seen you a couple times stumble when you have a minus and another minus.
Yeah.
All right. Nick, I gotta go. I will talk to you next time. I know you got finals coming up. If you need extra tutoring at all, make sure you schedule it soon. I'm going to be booked solid all next week and the first 2 days of the week after that.
All right.
Okay?
All right.
Talk to you later.
All right, bye.